Hello everyone, welcome back to College Algebra. So let's continue with polynomial function. Last time we already learned the general form of polynomial function, the standard form I mean, the standard form of polynomial function, and the polynomial function also has another form we call the factoring form. But before we start with the factoring form, let's do a quick recall on what we already know about polynomial function. Okay, so again, I'm going to put the topic today with the polynomial function. Okay, now let's do a quick recall first. Alright, so we know that polynomial function could be something like this, right? Be something like this. Alright, and you see the intersection point over here, intersection point right here, we call the x-intercept point. So we have three intersection points. Okay, so this point right here, this point right here, this, and this. So totally we have 5 intersection points. So intersection point is actually is the solution. We can call it the solution of polynomial equation. Okay, solution, or we can call it 0. Okay, we can call it 0. So last time I introduced the standard form of polynomial function, and in order to find the intersection point between polynomial function curve and x-axis, you can use the TI-84 calculator to plug it in to find the 0, the intersection point. And in the calculator we call that 0. In class I never show you how to do that, but actually you can you can go ahead and look it up on Google, and you see that we can use that to find the intersection point. Okay, you can find intersection point right there. If I have time, I'm going to show you how to do it, but it's not really that hard. We in this class, even though we are allowed to use calculator, but I don't really focus too much on calculator. However, probably in my math lab, they ask you to find intersection point, and the best way and the fastest way is to use calculator. Then if you see something like that, you can just go ahead and ask me. Okay, I will show you how to do it with your calculator, or maybe if we have time in class, I'm going to show you how to find intersection point between the polynomial curve and the x-axis. Okay, so that is what we know about polynomial function in standard form. Now polynomial function is also okay. What is standard form? Let's do a quick recall on that one too. So the standard form will be something like this, right? F of x equal to a n xn plus a n minus 1 xn minus 1 plus a n minus 2 xn minus 2 dot c0, and c0 is the y-intercept value. So this is a y-intercept value. Okay, and you see that if they give you something like this, if they give you something like this, it's kind of very hard to find intersection point without calculator. However, this is just the first form of polynomial function. Polynomial function also has another form. Okay, there's another form we call a factoring form. Factoring form of polynomial function. Okay, so what is factoring form? Okay, all right. The factoring form it will be something like this. Of course, must be in everything must be in product form, right? Because factoring it means product. So it will be something like this: a x minus z1 m1 times x minus z2 m2 times x minus z3 m3 dot times x minus z n, okay, and 3 m sub n. Alright, so how we understand this? So first of all, we know right away this is in the product form. In what is z1? What is z1 and what is m1? And what is the a value? Oh, over here, a value over here is a leading coefficient. It's a leading coefficient. Okay, it's leading coefficient. Okay, and the z1 to z sub n here actually is a 0. It's a solution, or it's a 0. It's a solution, or actually it's the intersection value. I'm gonna call this intersection value. So 0 or intersecting value between the graph and the x-axis. So this is the x-axis. Okay, and what is m1? m1 to m sub n here we call the multiplicity. Okay, we call it multiplicity. So what is multiplicity? Well, actually, if just think about it, if m equal 2, then basically it is x minus z1 times x minus z1, right? So actually it tells you how many times the factor multiply each other, huh? And the multiplicity over here, of course, it must be a positive integer. It cannot be negative, you know. It cannot be negative. Okay. Now, let me give you the example so that it's easier for you to visualize, to understand. I can have something like this. What if I have a polynomial function in factoring form like this: 2x minus 1 raised to the second power x plus 3 raised to the first power. Here you go. This is polynomial function. So in factoring form, you see the a value is here is 2, and over here is the number 2 over here is m1, right? And this is m2. M2 over here will be 1. Okay, m2 will be 1. Actually, it doesn't matter. It doesn't matter. Sometimes they put everything out of order. This is just the name. Okay, it's m1, m2, m1. As long you know that the m2 over here, the m1 over here, which is the multiplicity over here, is corresponding to this 0, and multiplicity over here, which is 1, corresponding to this 0. Okay, so this is a typical example of a polynomial function in factoring form. Or I may have something like this. The a could be negative, because last time we already talked about the ending behavior, right? The ending behavior can be determined by using the leading coefficient and the highest degree of polynomial function in standard form. So the highest degree over here is n, but what is the highest degree over here? When we dealing with factoring form, we're gonna go through the example so that we can determine the highest degree and the leading coefficient, because sometimes the value in the front over here is not the leading coefficient. Most of the time, yes, but sometimes it's not. For example, in this case, I have a -3, 2x plus 4 raised to the third power, and over here x minus 4 raised to the second power, and over here is 3x minus 5 raised to the 4th power. Here you go. This is also a polynomial function in factoring form. Okay, it could be like this. You see, it's a little bit different. You see that it's not just x, but this is 2x. It's not just x, but it's probably 3x. But it's still considered as polynomial function in factoring form. Or even I have something like this. What if I have something like this? I have a -1/2 x minus a half, okay, square, and this is x minus pi raised to the third. Here you go. This is also a polynomial function. It's just the z over here is different. The z over here is a fraction. The z over here is a pi, but it's still considered as polynomial function, because everything, you see that the multiplicity, all the multiplicity over here is an integer. A positive integer. We don't have negative integer. If it is negative integer, then it's not a polynomial function in factoring form anymore. For example, I have something like this. What I have, what if I have 3x plus 2 raised to the negative 3 times x minus 1 raised to the second power. Here you go. This is not polynomial, not poly function, because you see over here the multiplicity over here is not positive integer, but instead it is negative integer, so it's not polynomial function anymore. Okay, so you have to notice that. Okay, so you see that when you factor the trinomial, right, the ax squared plus bx plus b, and you factor them out, you see that actually what you did, you put in factoring form, right? So that is polynomial function. We already talked about that last time. Any trinomial function, which is any trinomial function in the form of ax squared plus bx plus c, it is polynomial function, and we call them the second degree polynomial function. Okay, so think about that. If we have it in a standard form, we look at the highest degree, we know right away. The highest degree, we know right away what degree of that polynomial function. However, if it is in factoring form, then how do I know the highest degree over here? And how do I determine the leading coefficient? And how do I know how to determine the domain and range over here? The range could be hard. Probably the domain we can determine, but the range could be hard. And can we find the only zero? Can we find the multiplicity over here? Okay, all the question over there can be answered with the second example I give you here. So this is the first example. Excuse me. So the second example is this. So I'm gonna give you let's use this one. Okay, let's use this one. This the simple one right here. What if I have fx to x minus 1 squared x plus 3? Okay, and I want you to determine the first question, determine 0. Okay, 0. It means on the intersection value. Okay, and multiplicity. Okay, and multiplicity, and they also determine if the graph is touching. Okay, the graph is touching or crossing at the 0. Alright, so we need to figure out that. So the second question over here is I want you to find in order to find all find all x-intercept point, and y-intercept point. Okay, and part C, I want you to find the ending behavior for this. Alright, so before we jump to the answer, before we start answering the first question, maybe I'm gonna miss something over here, so I'm gonna add a little bit information for you to determine whether or not the function is crossing or touching at a certain 0. So if the multiplicity, which is the m value is even, then it will be touching. Okay, and if m value is odd, then it will be crossing. Okay, what crossing? I mean the graph crossing the x-axis. Touching, I mean the graph will be touching the x-axis. Okay, and this is where we're talking about a graph. Okay, alright, so let's answer this. Let's answering all the question here. Let me see. So in order to answer, I think I can use some different color here. Can we use different color here? Just for fun, okay? Just for fun. Okay, so it's our answer. Okay. So determine the 0. Okay, so in order to determine the 0, the 0 is right over here, right? So in order to determine all the 0, you're gonna set each factor equals 0, and so for x. Alright, so for x, set each of them equals 0, because we have only 2 factors, so we can solve for the 0. So the 0 over here is z1 equal 1 and z2 equal -3, and z1 will corresponding to m1, right? So m1 will be 1, which m1 will be 2 for the multiplicity corresponding to the z, and the multiplicity over here m2 will be 1, because it's invisible 1. They don't write a multiplicity over here because the exponent is 1, so multiplicity over here will be 1. Okay, and so that is the 0 multiplicity. And how do I know that's cross and touching? So the multiplicity over here is even, so this could be touching right here, huh? Touching x-axis, and over here will be crossing x-axis. Here you go, that's easy, huh? That is how you answer the first part. Now on the second part, they ask you to find all the x-intercept point. That will be easy because we already know the x-intercept, the intersection point between the graph and the axis already. So the x-intercept point will be that intercept point. However, because this is point in this case, I'm gonna put it in the order pair form. So the first point will be 1 0, and the second point will be -3 0. All right. Okay, so actually the 0 and the x-intercept point or the solution is the same thing. However, when we mention x-intercept point, because it's a point, you gotta put in order pair form. But when we mention 0, all you have to do is put the value. Okay, the value. So the value is 1. Okay, this is the solution. When you write it in the x form, it is solution. When you write it in the z form, it is the 0. And when you write it in the order pair form, it is become x-intercept point. However, all of them is basically the same. Okay, then how we find the y-intercept point? Alright, in order to find the y-intercept point, we already learned how to find that. You're gonna replace the x with 0, so you're gonna have 2 0 minus 1, right? We already learned this intermediate, so replace the x with 0 to find the y-intercept point. So what you have left is 2 times 3 is 6. So the y-intercept point will be 0, 6. Of course, because this is a point, so you must write it in order pair form. Okay. Now part C. Okay, part C. Find ending behavior. Okay, so in order to find the ending behavior, because last time we talked about ending behavior, right? And I categorize it into 4 different cases, right? It depends on the leading coefficient and depends on the highest exponent of the polynomial in standard form. However, because this is not standard form, this is factoring form. So how do I determine the a value, and how do I determine the highest exponent? Okay, just imagine. In order to convert it to standard form, all you have to do is expand this, right? You expand this, you expand it. This is a second degree and this is a first degree. So when you expand it, so the highest degree, which is the n value over here is second degree and 1 degree over here. The highest degree over here is 3. Okay, the n value is 3. How about when you distribute it? You distribute the a, the leading coefficient that attached to the highest degree term is also a, which is also 2 over here. So the leading coefficient in this case is also 2. So a is positive, n is odd, right? N is odd. So what we're gonna have? So we're gonna have something like this, right? Gonna be, what case is that? I don't know what case, but I mean I know that because this is odd and this a is even. A is positive. So this is odd. So we're gonna have one branch going down like this, and the other branch going up like this, right? Because it's odd. Yes. Okay. So one branch going down like this, and the other branch go and apply this to the right hand side, right? Because it's odd, and it's because A is positive. If it's negative, then the other way around. So from here, I can write a learning the ending behavior will be when x approaches to positive infinity, right? Then y approach to positive infinity, and when x approaches to negative infinity, then y approach to negative infinity. Here you go. That's its ending behavior. Okay, so you must know how to do it based on the highest degree over here, and the leading coefficient, which is the positive. In this case, this is positive. Okay. Alright, so that's the first example. However, sometimes the value in the front of factoring form is not the leading coefficient. Most if it is this form, it's a leading coefficient because there's no value in front of each x over here. Now, what if I have something like this? Example number 2. What if I have something like that? And let's see how we're gonna answer all the question over there. What if I have like this? I have negative 3 and 2x minus 3 raised to the third, and 3x plus 6 raised to the second. Okay, and x minus 1. Okay, what if I have something like this? Let's see is this one is still the leading coefficient or not, and which one, or is this how we determine the degree, the highest degree. Okay, so how we determine the degree of this polynomial function. So the answer will be the same. Okay, so I'm gonna go ahead and try to find I mean, the question will be the same. The question will be the same. So I'm gonna go ahead. I won't be writing the question down anymore. I just go ahead and answer. Okay. So the answer. So the 0. Okay. In order to find all the 0, so you're gonna put each of them equal to 0. Okay. So solve for x. X equal 3 with 2. Okay. Then you raise it. And 3x plus 6 equal to 0, so you have x equal to negative 2, x minus 1 equals 0, so x equal to 1. There you go. So you have 3 solution, and that's why we have 3 zeros. So z1 will be 3 with 2. That corresponding to multiplicity over here will be 3, so m1 will be 3. Z2 will be negative 2 corresponding to m2 will be 2. And z3 will be 1 corresponding over here will be also 1, and 3 will be also 1. Okay, then the multiplicity, that's the multiplicity, so it will be over here because the multiplicity is odd, so it will be crossing the x-axis. It will be, this is touching the x-axis, and this will be crossing the x-axis. Okay, on the test I won't give you this. Okay, I'm gonna ask you like this because I think I'm gonna put this type of question on the next test. However, on the second part of this video, the second part will be on the test, but not this one. Okay, not this one. Okay, so that's part A, and part B, you know, find the x-intercept, easy. X-intercept point. The domain and range. The domain is from negative infinity to positive infinity, but the range is different. We cannot determine the range because in order to determine the range, we need to find a maximum minimum point. But the domain of polynomial function, remember, the domain of polynomial function is always negative infinity to positive infinity. Okay, so I'm gonna add it over here. Domain is always negative infinity to positive infinity. No matter what. Okay, no matter what. Okay, so x-intercept point, we already got it. So it will be 2 points right here, right? Okay, so the first point will be 3 over 2, 0. Okay, negative 2, 0, and 1, 0. Here you go. And y-intercept point. Y-intercept point. There's only 1 point, so there's no plural right here. Okay, so put x equal to 0. So we can have z, or x equal to be y y equal -3. The 0 over here, so what you have left is -3 raised to the third. 0 over here, so what you have left is 6 squared. 0 over here is what you have left is -1. So the answer could be -3 raised to be -3. This is give you -27. This 36 is -1. That's a pretty big number. It could be negative something. 3 times 27 times 36. And go ahead and calculate it for yourself. Okay. Okay. Then the y-intercept point will be 0 and the negative comma right there. Okay, I don't have calculator here, so you go ahead and do it for yourself. Now, for this is where's the difference between second example and the first example. So, if we go ahead and say that the a value, the leading coefficient over here is -3, that would be wrong. You have to be careful because it's over here raised to the third, it's over here raised to the second. The leading coefficient over here 2, 3, and 1. So when you raise it to the third, give you 8. When you raise it to the second, give you 9. Right? 1 is just 1. Okay, so the leading coefficient is not -3 anymore, but -3 times each of the leading coefficient inside the parentheses will be -24 times 9. Again, it's still negative number. It will be something, right? It will be something, but I know this is negative. I know this is negative because actually we just need to know it's positive or negative. You know. And the n value over here, the n value will be the n value is going to the third power, this to the second power, and this is first power. So the n value will be actually 7. No, will be 6. Sorry, 3 plus 2 plus 1 is 6. Okay, it's 6. Okay, so last time is 3 because this is 2 plus 1 is 3. 2 plus 1, but this is 3 plus 2 plus 1 is 6. So n is even. It's even. So what will be our ending behavior? So if it's even, actually I'm gonna just go ahead and I don't have enough space over here. So it's a is negative and n is even. So my sketch will be something like that, right? A is positive and n even, so even. So gonna be 1 up here, alright, and the other branch will be like that. Okay, and it's even, and a is positive. So it's both of the n is kind of going upwards. So from here I can write the ending behavior. If you go ahead, you guys forgot, go back to the one of the categories I provided in class. Okay, so go ahead and look at on the table you see. So when x approaches to infinity, right, positive infinity, then y approaches to positive infinity because it's keep going up. And when x approaches to negative infinity, it means you keep walking all the way to the left, right? To the left. Then y keep going up, right? Keep going up. So y approach to positive infinity. Here you go. So this is ending behavior, okay? So this is what I want you to show on the test. If I give this type of question on the test, okay? Good. Now, so that is the factoring form of polynomial function. Okay, this factoring form of polynomial function. It's kind of very easy to determine the zero, right, and the multiplicity when or the solution when the polynomial is in factoring form. However, what if they give you something, a polynomial function in standard form? Then it's kind of very hard to find the zero and the multiplicity, right? We don't know where it's touching, we don't know where they're crossing. So if they give you something like this, not the factoring form, but instead they give you standard form, something like this, which the one we already learned in class. Okay, the one we already learned. So how are we gonna convert? How are we gonna convert standard form to factoring form? Oh, that could be this very good question. That was very good question. So on the second part of our lecture today, okay, I'm going to show you how to convert from standard form to factoring form using a concept. Actually, this concept you guys already learned in probably elementary school, but probably many of you did not really notice at that time because we are too small, right? We're like small kid and we don't know. And I also introduced two theorem that will help you to determine the factor of polynomial function. Okay, so let's jump to the second part. Okay, so on the second part over here, I'm going to put method of determine. Okay, method of determining factor and zero of poly function. Okay. So in order to determine the factor and zero of polynomial function, actually we use a concept we already learned in elementary school. Actually, we use the division rule. You know, I don't know. You guys still remember how to divide, how to set up division? You know, back in the day, remember we learned how to divide 6 by 3, right? Something like that, right? When you divide 6 by 3, you set it up when you write like this, and actually this is the same way as you set up like that, right? It means 2 going to 6. So how we do that? Anyone still remember how to do this? I mean, this is like elementary. So 2 divided by 2 going to 6, or 2 going to 6, and you ask yourself how many times 2 going to 6, right? And you can answer is 3 times, right? Here you go. You put 3 over here, and you multiply them back, all right? And you multiply them back, you 6, and you do subtraction, which is give you 0 here. So that is how you do division when you were in elementary school, right? Or something. What if I want to divide 7 by 3? Okay, 7 by 3, and this is how you set up. You set a 3, and you do like this, and right, and you ask yourself how many times 3 going to say 7, or how many times 3 what value so that 3 going to 7, but that's really close to 7, because I know that 3 going to 7 it doesn't work, but the value that's the value that 3 going to 7 that give you something close to 7 could be 2, right? Because 3 to 7 would be 2 times 3 is 6, because if you do 3 times 3 would be 9, more than 7, so this doesn't work. So this should be 2. 3 going to 7, the closest value we have is 2, it's not 3, so which is give you 6, right? And when you do subtraction, you have 1. Okay, so what is the name of number 3? What is the name of number 2 over here? What is 3 over here? What is 0 over here? What is 1 over here? What is 2 over here? I don't know, you guys still remember, but as far as I remember, this is called, okay, the 0 over here we call the remainder. So we don't have remainder. 1 over here, remainder over here is 1. Number 2 and 3 over here, number 2 right here, we call the quotient. This is called quotient. That's quotient. Then what is 6? What is 6 and 7 here? 6 and 7 we call that, anyone remember? We call dividend. Dividend. This is also dividend, kind of pretty long time ago, right? And number 2, what we call number 2? Anyone remember number 2? We call Number 2 is divisor. Divisor. So it's divisor. Okay. So basically, the way we can set it up like this is actually it actually based on a rule. Okay, we call that division algorithm rule. Okay, and we're going to use the division algorithm rule to divide polynomial. And just think about that. Just think about that. If you divide polynomial, right, and the remainder is 0, it means the quotient. Just think about it. The quotient will be the factor. The quotient will be one of the factors. Over here, the remainder is 0. So that's why the quotient over here is 3. So 3 is a factor of 6, right? 3 is a factor of 6. Okay. However, over here the remainder is not 0. Then of course 2 is not a factor of 7. So that is the way to do division. To find a factor, a polynomial function. Okay. So the division over here is based on a rule we call that division algorithm. So that's called division algorithm. So let me erase this. So let's talk about division algorithm first. Okay. So let's use this division algorithm. So back in the day when you learn when you're in elementary, so you learn it. Actually, the teacher never mentioned this term, right? Because it's this pretty high level math. So they just show you how to set up. Actually, you don't know what's that for and what it's based on. Actually, it's based on division algorithm. So the division algorithm states that what if you have fx, okay. Fx, which is you want to divide by dx, which is the divisor. Okay, then it give you what? It give you quotient, which is whatever you have here. Okay, whatever you have here, and also you have the remainder. We call Rx. Okay. Remainder. We have remainder. Okay. All right. So in this one we can rewrite it as fx equal to dx times qx plus remainder. So why I have to write it in function form? Because we are talking polynomial. Okay. So actually this is a polynomial. Okay. When you divide a polynomial, so this is dividend right here. This is dividend. Okay, this is a divisor. The divisor is polynomial. The quotient is also polynomial, and the remainder is also a polynomial. Because we're not dealing with number anymore. We're dealing with function, right? So we have the polynomial divided by polynomial, which is of course giving polynomial, and the remainder, of course, is also polynomial. Sometimes the remainder is just a number, but the number is polynomial. Okay, it's just we call that monomial, right? So all of them over here we have a function divided by function, give you the function, and the remainder is also a function, polynomial function. So this is we call division algorithm over here. Okay, and let's see how we're gonna use this to determine the factor. Actually, okay, other than division algorithm. Okay, other than division algorithm, we use the concept of determining the factors is also based on two theorem. We call that factoring. We call this the remainder theorem and factoring theorem. Okay, but I think I'm gonna mention that later. Okay. I'm going to mention that later. So right now at this moment, I'm going to just give you example, but I'm not going to show you how to divide yet. Okay, so I just give you example. What if I have fx like this? Okay, dividend like this. What if I have 6x to the third? Okay, minus 2x squared Okay, minus 3, here you go, and I want to divide it by this polynomial. Okay, so I have dividend, I have divisor, dividend, divisor. Or what if I have all of the polynomial? Polynomial. This is second degree, the first degree, and the third degree. All of the polynomial. Or what if I have something like I have negative 5 plus x plus 4x squared plus 2x to the third plus 3x to the fourth. You divide it by x squared plus 2. This is also this is a dividend, and this is divisor. Okay, so we're gonna learn how to divide this, and the answer is the quotient. The quotient answer is the factor of polynomial of this polynomial if the remainder is 0. Okay, if the remainder is 0. How do I know that? Actually, that concept is based on a very important theorem we call the remainder theorem and factorial. We're going to talk about that also. Okay, so that is the first way to do division. We use the division algorithm concept. As another way of doing division, okay, we call it synthetic division. So let me see which one should I introduce first. Okay. Let's talk. You know what? Let's talk about the remainder theorem and the division and the remainder theorem and factor theorem first before we do synthetic. Okay, before we do synthetic. Okay. So second. Factor theorem, remainder theorem. Okay, so what is remainder theorem? What is remainder theorem? Okay. Okay. If a poly function fx is divided by x minus c, okay, then the remainder is fc. Okay, the remainder is fc. Okay, so if we have a polynomial function and we divide by a first degree polynomial function in this form, okay, in this form, then whatever the remainder is will be the output of the input c. Okay, will be the output of the input c. So this will be the f of c. You know how you calculate f of c? F of c, you plug c into the function, right? So f of c will be, after you plug it in, you calculate it. So f of c will be the value after you calculate it. So the remainder tell you that the f of c will be actually is the remainder when you do division. When you do division, let me give you example. Let me give you example. What if I have you know what? I think I'm gonna just go through all the theorem first before we doing really doing example. Okay, number 3. Number 3 is factor theorem. Okay. If fx is polynomial function. Okay, left. I'm sorry, left. That is a function. If f of c equals 0, then x minus c is a factor. Okay. If x minus c is a factor, then f of c equals 0. So actually this statement over here are equivalent to each other, you know, equivalent to each other. Okay. So think about if you have f of c equals 0, f of c equals 0, which is the remainder is 0. That's what it means. Okay, if the remainder is 0, then x minus c is the factor. That's all. Okay, make it simple like that. All right. Now we're gonna do the example. But the first example I'm gonna use a division algorithm. Okay, division algorithm to get the quotient first and to see if the divisor is a factor. Okay, or if the quotient is the factor. Okay, example number 1. Okay. Let's do this one. Okay, let's do this one. So I'm gonna go ahead and set up division, the division algorithm. Okay, so I'm gonna have the divisor like this, right? And I wanna go into dividend like that. And you see this third degree, second degree. So make sure you put everything in order. And the next one will be 0 degree, right? But we don't have it, so I just put 0. Then the last one is. If you're missing any term, you gotta put 0. Okay. Remember, if you're missing any term, you gotta put 0. Okay. Okay. So you're gonna do the same way as you do the regular division. You're gonna ask yourself. You pick the first term of this. You divide by this. So you ask yourself, how many times 3x go into 6x to the third power? It's like you set up like this. Okay. How many times? 6 divided by 2, 3. X 3 divided by x is x squared. So 2x squared. Take the first term of this divisor and the first term of dividend. Okay. First term dividend. First term dividend. All right. Go ahead and multiply them by. You see the same way as you learn. And you learn the division when you have elementary ratio. So multiply them by, which is 6x to the third. 2x squared times 2 is time plus 2 is 4x squared. There you go. And you do subtraction. Just give you 0, right? You give negative 9x squared. Okay. Got negative 5 minus 4. Okay. You subtract the whole thing. Okay. Negative 5 minus 4 is negative 9. I drop this one down. When you drop this one down, actually there's nothing. Okay. Okay. I'm gonna drop one by one, you know. So I'm gonna keep going. Negative 9x, 3x, negative 9x squared divided by 3x. I give you negative 3x. Okay, negative 3x. Multiply back into negative 9x squared. Oh, we don't have 0. We don't have negative 3x times positive 2, negative 6x. Okay, subtraction. And remember, when you do subtraction, you change the sign, so it becomes 6x squared. And you drop. Now you're gonna drop negative 3 down. Okay, you drop negative 3 down. So what it give you? Oh, this is negative 6. I'm sorry. Alright. Now 3x divided by 6x, right? 6x. Divide 6x, so 6x over 3x will be 2. So it will be 2 over here. Alright, 2 times 6x. Multiply them, 2 times 2 is 4. There you go, do subtraction, give you negative 7. Ah, so the answer is negative 7. What does it mean over here? This is the remainder. We have to stop right over here because the negative 7 is the degree is smaller. This is 0 degree and it's the first degree. So if it is smaller, we cannot do more division. Okay. So this is the remainder over here. This is the remainder over here. So what does it mean? It means what? What does it mean? It means that the quotient here. It means that over here the quotient over here is not a factor because the remainder is not 0. If the remainder is 0, if the remainder is FC, right? FC is 0, so over here, -7 over here, it's not 0. So the quotient over here is not the remainder. Okay, the quotient over here is not the remainder of that. All 3x plus 2 is not the remainder. Okay, none of them is the remainder. Hey, I'm sorry. Just go ahead and ignore it. Then, because the remainder is -7, then the quotient over here is not a factor. I just keep saying remainder. This is not a factor. This is also not a factor. Okay, it's not a factor over here. So, because the remainder is different from 0, okay, that's why it's not a factor. Okay, it's not a factor. Okay, sometimes if the remainder is 0, then it is a factor. If the remainder is 0, then it is a factor. For example, let me give you something when you have 0 as the remainder. Let me see. Okay. What if I have something like this? Okay, what if I have this? So hold on. I think I'm gonna give you another one, okay? Because you need to get used to the division first. Then we're gonna talk about remainder and factor. So that's how you set up division. Okay, that's how you do division. There's another way. Let's do the second example. Let's do a second example. Then we talk about remainder and factor later. Well, actually, I already talked about it, but I'm gonna talk about that again. Okay, second example. Okay, so I'm gonna go ahead and use the one right here. Okay, I'm going to use this one, but this is, you see that they put out orders. So I'm going to rewrite it with, this is the highest degree. Okay, so let's rewrite it. So this is, so x squared plus 2 is the dividend, it's the divisor, I'm sorry, and this will be dividend right here. Let me rewrite it. 3x to the 4, 2x to the 3rd, 4x squared plus x minus 5. Okay. Okay. So let's do it. I pick the first term here and the first term over here. Okay. So you have 3x to the 4 divided by x squared, which is 3x squared. Okay, 3x squared here. You multiply them back, which is 3x to the 4 plus 6x squared. Do subtraction, which is to give you -4x squared, and you're gonna drop this down. Okay, and now a -4x squared divided by x squared. Okay, take the first term here and the first term here. Okay, which is -4. Okay, -4x squared, -8. Oh, they're missing the x over here. So they're missing, you see this one, they're missing the 0x. I'm sorry. This is 0x plus 2 because they're missing the term, so I gotta put the 0x. I forgot to put the 0x. So we have 3x to 3x. Okay, let me see. Let me read this. Is -4. Yeah, -4x squared minus. No, hold on. I think I messed up something. I'm sorry. Let me redo this. So subtract it, give you this, right? I think okay. Let me multiply with this. Yeah, so right here is wrong. Right here, I'm sorry. Okay, because I'm missing the term, so when I multiply them back, so give you 3x to the 3rd. Okay, then 3x. Then 6x squared. Okay, right there. Okay, so let you write this. Sorry guys, yeah, got missing the term. If you're missing any term, you gotta put 0, okay, because otherwise everything will be wrong. So you have 2x to the third, okay, subtract them. Okay, this is negative 2x squared, right? There you go, it's better. Okay, now you're gonna drop the x there. Alright, let me erase this. Okay, this is not right. Alright, now 2x to the third. 2x to the third divided by x squared will give you 2x, right? So this is going to be 2x. I'll give you 4x to the third plus 0x squared plus 4x. There you go, do subtraction. We give you what? Okay, give you 0 minus 2x squared minus 3x. Okay, now you drop number negative 5 down. Okay, you drop negative 5 down, which is x squared divided by negative 2, which is give you negative 2. Okay, negative 2 times x squared, negative 2x squared. Minus 2 minus 0 x minus 4. So this is give you subtraction. So give negative 3x. Okay, minus 1. Okay, minus minus become positive. Minus 5 plus 1 is negative. Okay, so this is the remainder because the degree over here is smaller than this. So the remainder is this. So the remainder is not 0, right? The remainder is not 0. So the quotient, what can I conclude over here? The quotient over here and the divisor over here is not the factor. It's not a factor. Okay, this is quotient, but it's not a factor. Okay, all right. So let me give you something so that when we do division and the remainder is 0, what if I have this? Yeah, okay, what if I have the example number 3, okay? Alright, so now what if I want to do this? Okay, I divide this by x to the 4 minus x to the third minus 11x squared plus 11x plus 12. Okay, let's see the remainder is 0 or not. Okay, again, I'm going to take the first term here and the first term here. So x to the 4 divided by x give you x third. You see that you got to be really good at exponential simplification. And the concept is exponential simplification we already learned in intermediate algebra. You know, we just give you x to the third. I multiply the math, give you x to the 4 minus 3 x to the third. You see that we're not missing any term. Okay, 4 3 2 1 0. This is 1 0. Okay, 1 3. Okay, so the degree, I'm talking about the degree, we're not missing any degree, so everything's good. Because if we miss a degree, we gotta put 0. Okay, so you go from second degree, then you should go to the first degree. That's why we don't have the first degree, we gotta put 0, right? Okay, alright, and let's do the subtraction, which is give you negative will be 2x to the third, right? Because negative become 3 minus 1 is 2. Alright, drop is 1 down, drop 1 by 1. Okay, don't drop everything. This go into this, give you 2x squared. Multiply by give you 2x to the third minus 6x squared. Okay, do subtraction, which is negative become positive 6. 11 plus 6 is negative 5x squared. Drop 11 down. Okay, this is okay. This is drop 11 down. Okay, give you negative 5x, right? Negative 5x, which is give you negative 5x squared, 15x. Do subtraction again. So negative minus over here, negative 15, 11 and negative 4x. Alright, now you drop 12 down. Okay, negative 4x, you go to x, give you negative 4, negative 4x, negative positive 12, do subtraction. Here you go, it's 0. Negative, negative become negative 12, cancel. So the remainder is 0. This is remainder. And the remainder is 0. That's why. So we can conclude. We can conclude that. What can we conclude over here? We can conclude that x minus 3 is a factor, as well as x3 plus 2x squared minus 5x minus 4 is also the factor. It's not just a nice factor. This is a nice factor. This is also the factor, but maybe because this is a polynomial, we can factor more. But this is considered a factor also. A factor of what? Both of them over here are a factor of x to the 4 minus x to the 3rd minus 11x squared plus 11x plus 12. Okay, so this is x to the 3rd is a factor. Okay, because the remainder is 0. Other than that, based on the factoring theorem, we also know that f, because x minus 3, we know x minus 3 over here is a factor, right? And that's why we can conclude more. We can conclude that f of c, which is f of 3 over here, f of 3 equals 0. There you go, because of the factor theorem here. Okay, f of 3, because if x minus c is a factor, then f of 3 out of c equals 0. X minus 3 is a factor, then f of 3 equals 0. So because we use the concept of factor theorem right there. Okay. All right. Okay. Good. Right. So that's how you use long division. That's called long division, or we call that a division algorithm to check if x minus c is a factor. Okay, if x minus c is a factor. Okay, there's another way. Okay, another type of division we call synthetic division. Okay, we call synthetic division. And the way we set up synthetic division, we're not doing the algorithm anymore. Okay, instead we're using the coefficient to do synthetic division. Okay, so on the fourth part, I want to talk about synthetic division. Okay, synthetic division. Okay, so let's start with the example to see the difference between synthetic division and long division, which is the regular division we do one over here. So this is called the long division. I'm sorry, we cannot even move this. So this is a long division right there. This one, all the example over here is long division. So all of this is long division. I think I missed something, right? I think there's another. Let me see. Yeah, there's a long division. All of this is still long division, but for some way somehow I think I messed up a little bit over here. I'm sorry, because this, I don't know why I put the synthetic division right here. I think I put it in the wrong place. So yeah, so let me erase this. Okay, let me erase this. Okay. So this is first example. So on the page on the next page I have here is a second one and a third one. So I should put thin syntactic division down over here. Okay, so it is number 4. Number 4. Oops. Right here. Synthetic division. Okay, let's start with our first example. I don't know, you may want to use a different color, so I think I can use this color right here. Here you go. You know, try to make it colorful a little bit, huh? It's good for the eyes. Okay, so let's do this. I want to divide the polynomial here, 3x to the third power plus 25x squared, okay, plus 42x minus 40, okay, and I want to divide this by x plus 5. Okay. So before I start the example here, I just want you to notice this, because synthetic division is kind of very picky, because it's not all polynomial we can divide. For regular division, which is the long division we did in the first 3 examples, that's called long division. For synthetic division, we can only divide it by the first degree. Okay, so I'm going to put a notice right here. Let me use different color here. Okay, so the divisor must be, okay, must be first degree. Okay, it must be first degree in the form, okay, x minus c. It must be in this form. You see that it's in the form over here. The c over here is the c over here is minus 5, so minus become plus right here. So this is a divisor. Divisor must be this in order to do synthetic division. If it's not in this form, which is this one right here, then we cannot do synthetic division. Okay, so you can do the long division, the one we already learned here on the first 3 examples, but you cannot do synthetic division. Okay, so long division is good. It's kind of popular because it's powerful, because it works all the time. But for synthetic division, you can only divide it by the x minus c. Okay, now let's start with our example right here. Okay. So the c over here, you recognize the c over here is minus 5. So that is how where we're gonna set up. Okay, so we're gonna step up minus 5. Okay, and we're gonna put all the coefficient of the dividend polynomial. So it will be 3, 25 here, and 42 here, and negative 40 here. Okay. Alright, I'm going to put everything over here. Okay, so that is the first step to do for synthetic division. Then you're gonna draw, you cannot draw the line like this. Okay, then you drop down number 3. You drop the first, the lead coefficient over here. You always drop it here. Then you take this. Okay, you take this, multiply by this. Okay, 5 times 3, negative 5 times 3, negative 15. Then you add them up. Okay, you add them up, give you 10. Okay, and you take negative 5 again, you multiply by, you keep multiply by 10 to give negative 50, and you add them up, give you negative, and you keep doing like that. Okay, and you see that the last number you have after you adding up is 0, right? Here you go. This last number here is the remainder. Look at that. So the remainder right here, the remainder is 0. It means what? The remainder is 0. It means, okay, remainder equals 0. It means that x plus 5. It means that x plus 5 is a factor. Okay, it means x plus 5 is a factor. So according to the remainder theorem, it means that it also means that f minus 5 equals 0. There you go. So that is how you use syntactic division to determine a polynomial is a factor of the dividend polynomial. Okay, of the dividend polynomial. Okay, so that's how you do it. Okay, but of course sometimes the remainder is not zero. If the remainder is zero, that's good. Okay, if the remainder is zero, is excellent, it's great. But what if it's not zero? What if it's not zero? What can we do? All right, for example number 2 right here. Okay, what if it's not zero? Let's see, I can find something where it's not really zero. Let's see, how about this one right here? Remember this, okay? So the divisor must be in this form, okay? If it's not in this form, then we gotta do something else. We gotta do it, but I mean, at this level, it's not pre-calculus, so I'm not gonna go too deep into that. But let me see if it's not zero. Oh, how about this one right here? I want to divide this one, so we have 2x. 2x 1 2 3 4 5 2x to the 4 minus 5x to the 3rd minus 5x squared minus 4x and plus 29. Okay, so that's the dividend polynomial, and I want to divide it by x minus 3. Okay, so you see that my divisor is always in this form. Okay, if it's something different, then we cannot do it. Okay, for example the one right over here, I can do syntactic division here because it's minus c right here. But look at this one, I cannot do this one because this is x squared plus 2. I cannot do syntactic division here. I must do long division, which is the way we set up like this. This is called long division. Okay, all right. So let's set up syntactic division. So my c over here is 3, so you can go ahead and set up 3 here, and make sure that we're not missing any term. So we have 4 3 2 1 0, so it seems to be good. So I have 2 negative 5 again, and negative 4 here, and the last one is 29. Okay, then you draw the line. Okay, you draw a line right here, and you see that this number 2 is always drop down, huh? When you multiply this, will give you 6. Add them up, give you 1. Then you keep multiply 3 times 1, give you 3. Add them up, give you negative 2. You keep multiply, give you negative 6. Add them up, give you negative 10, negative 30, and you add them up, it give you what? Give you negative 1. Oh, this is the remainder right here. Alright, this is the remainder over here, and the remainder is not equal to 0. So from here, I can conclude that, okay, I can conclude that x minus 3 is not a factor. It's not a factor of polynomial of 2x4 minus 5x3 minus 5x squared minus 4x plus 29. So it's not a polynomial. Okay, so where is the quotient? Maybe on the first exam, maybe some of you are gonna ask yourself like, where the quotient at? Okay, actually the quotient right here. So this is the 4th degree, right? And this is the 1st degree. The 4th degree divided by the 1st degree, it gives you the 3rd degree. So this is the number right here. All the number right here is actually the coefficient of the quotient polynomial. So where is the quotient polynomial? Let me use the different color. So the quotient polynomial is a qx, right? So the qx over here could be it could be the 3rd degree. So because the 4th degree divided by the 1st degree is the 3rd degree, you start with the 3rd degree. Okay, so you're gonna have 2x to the 3rd is the plus x squared minus 2x minus 10. Here you go. That's the quotient. So this is quotient polynomial. Okay, then what is quotient over here? That's what quotient over here. Quotient polynomial over here. This is the 3rd degree. We divide by the 1st degree, so you have the 2nd degree. So this the quotient polynomial here will be 3x squared plus 10x minus 8. Okay, whether or not this one can be factor, I don't know. Okay, we have to consider that, but I mean, at this level, you don't have to go too far. It might be that the quotient polynomial can be factor more, might be, because we want to think about it. We want to put the polynomial, okay, the dividend polynomial into factoring form. It means you have to factor everything. You have to factor everything out. That could be the very hard part. I mean, we're not gonna focus that part in college algebra. So you just go ahead. You just need to learn this. I think that's enough. Okay. You need to know the quotient. You need to know whether or not the x minus c is a factor. If the remainder is equal to 0, it means the c is the 0. F minus phi equals 0. It means, so I'm going to add a little bit information over here. So this is mean. In other words, this is mean negative phi is a 0. Okay, mean negative phi is 0, and because this is a remainder, it's different from 0, so it is mean 3 is not a 0. Okay, very important information there. Good. Okay. Let's see anything else. Okay, I can do another one. So that is the I can do another one. I think example number 3, huh? Example number 3. Let me see. How about this? Let me see right here. I try to find something interesting. Of course, well, I'm not going to give you something too hard, right? Because you don't need to deal with that part. I mean, but let's see. I try to find something missing the term, so that we can put the 0 in. Okay, how about this one right here? This is kind of very interesting. So far all the 0, right? All the c value. Okay, the c value over here. See the c value over here we have is a real number. So in this case, it's negative 5 and 3, right? What if the c value is not a real number? What if it's a complex number? Okay, what if I want to divide this? So I have a dividend polynomial like this, d of x, okay, equal to x to the third plus x plus 10, and I want to divide this. I want to divide it by the divisor. Okay, I want to divide it by the x minus 1 plus 2i. Oh, okay. So my c value here, is 1 plus 2i. Okay. I want to see it. I want to check if the c value here is 0 of this polynomial or not, or I want to check if x minus c value, which is x minus 1 plus 2i, is a factor of this one or not. So basically we do the same thing, but the c value is just the I number. Okay, so basically we're gonna set in the same way, so 1 plus 2i. Okay, and if you notice, you see that this is the third equation of 1, and you see the missing the square term, right? So it could be 0. Then the coefficient of here could be 1, and the last one will be 10. Alright, again, first of all, you go ahead and drop down number 1. Okay, then you multiply them up. 1 plus 2i times 1 will be 1 plus 2i. Okay, then you add them up. Okay, they give you 1 plus 2i, right? Then 1 plus 2i times 1 plus 2i. Maybe some of you have hard time doing that. You can work on the side. Okay, you can work on the side. 1 plus 2i times 1 plus 2i, which is give you what? Give you For them give you 1, 4i plus 2i square, right? I'm going to give you 1 plus 4i, 2i square give you 4 times I square, and I square give you negative 1, which is negative 4, so we just give you negative 3 plus 4i, okay, negative 3 plus 4i right over here, okay, negative 3. Is you can actually you do the same way, but you just have to do a little bit more work because it's a complex one. Alright, so add them up, okay, add them up, so it will give you negative 2 plus 4i, okay, and now you keep multiply this, so you have 1 plus 2i times negative 2 plus 4i, here you go ahead, distribute it, give you negative 2 plus 4i minus 4i plus 8i squared, this cancel out, so give you negative I squared is negative 1, give you negative 8, which is totally negative 10. Here you go, so this is give you negative 10 right here, and you add them up, it give you 0. Oh my god, this is remainder right here. Okay, so what does it mean? What does it mean? It means it means, so this is mean, it means that x minus 1 plus 2i is a factor of dx. Okay, it's a factor, or in other words we can say f of 1 plus 2i equals 0. So it had the same meaning right there, because the remainder is 0. Okay, so I can say that 1 plus or in other words we can say 1 plus 2i is a 0, of dx. Okay, here you go. So now you do the same thing when you deal with the complex number. Okay, so after you already know how to do division, how to factor them, you know the standard form, you know the factoring form. Now the next part, which is let me see what part we at right now. So so second part, a second Roman is here. Okay, so the first Roman is here. Okay, factoring form, second Roman, the method to determine and in the second one there are 4 of this, and the fifth one. Okay, let's just do the fifth one in the second part. Okay, so in the fifth one, okay, we'll be talking about how to write a polynomial, how to given certain information. Remember back in the day we learned how to write linear function, right? We learn we had to find the slope and the b, right? And in order to write the quadratic function, we have to find the a value and h and k, which is the vertex, right? And for the polynomial, we have to they must give you some information in order to write polynomial function. Okay, so the title for part 5 over here, I'm gonna put writing poly function. Okay, and again, I don't think that this will be on the test. It might be on the next test, but it's not on this test. So the topic on this test will be the syntactic division, which is in the example syntactic division and the long division, factor theorem, and remainder theorem. So also this, I'm going to give you something like this only. Okay, something like this. Example 3, or example number 1, 1, 2 right here, or 1, 2, 3 right here. Okay, long division right here. Okay, but writing polynomial is not on the test, but it's very important, so I have to cover that. Okay, and I just want you to know that every time they ask you to write or to set a polynomial function, you always use factoring form of poly function. Okay, always. Okay, you don't want to use the standard one because the standard is hard. It's very hard. Okay, so let's do this. Okay. Let's see. I'm gonna go ahead and change the color again. You want me to change the color? So we have, or maybe we gotta go back to the white one. Okay. Okay. Example. Write poly function of degree 3 okay that has 0 1/2 square root of 6 and maybe sorry. And it goes to 1. 1, 2. Okay, so let's see how we do this. Okay, so the polynomial function in the factoring form is this, right? A x minus z1, because there's only 3 zeros, so we have x minus z2, x minus z3, and you see that the question does not mention about multiplicity, so we assume the multiplicity must be 1. Okay. All right. If they mention the multiplicity, then we have to include the multiplicity. But other than that, this is just 1. Okay, so go ahead and plug them in. So they give you 3 zeros. So it will be x minus a half, x minus square root of 6, and it's x plus square root of 6. So our job is to find a value. So they give you 1/2 over here. Okay, so we're gonna go ahead and plug them in. So 2 will be this a, this is going to be 1. Okay, this is 1 minus square root of 6 and 1 plus square root of 6. Okay, and now we gotta find a value. So we have 2 1/2 a, and this one I can go ahead and distribute, which is give you 1 minus 6. All right, so this is give you 2 1/2a times -5, so give you -5a equal 4, a equal -4 over 5. Here you go. So that is your a. So as long as you get the a, then your function, okay, will be -4 over 5, x minus a half, x minus square root of 6, x plus square root. There you go. That will be your final answer. There you go. Okay. Okay. Maybe some of you kind of ask me, then where we use the degree equal 3? Actually, the degree equal 3 over here, it tell you that the first degree, the second degree, it tell you that we have 3 factors over here, right? Because the first degree is another degree, or another first degree. So you add them up, give you the third degree. Okay. Some problem a little bit harder, and it require you to do a little bit more. For example, I have something like this. Example number 2. Right, poly function of degree 4, okay, that has 0 1 -2 n I. Okay. Okay. And it has multiplicity let's change this a little bit. Have multiplicity. Okay, multiplicity. Respectively is 2, 1, and 1. Alright. So let's change this to 5. Okay. And goes to upon net 1, 1. There you go. How we do this? You will see a little bit different because in this case you see I include a multiplicity, and the degree is 5. However, look at that. I give you only 30, right? 30, but the degree is 5. So what is how we write that? So usually we have a, right, x minus 1, right, then x plus 2, right. Right here we have the multiplicity is 2, so it will be 2. Multiplicity over here for negative 2 is 1, right. The multiplicity over here is also for I is 1. But you notice this, because I is a complex number. So if you go ahead right now, add them up right now, you see that 2 degree, 1 degree, another 1 degree give you only 4, right? So they're missing another one. Because the complex number over here, it tell you that if x minus I is a complex number, is a factor, actually x plus I also a factor. So that is the part you have to notice. Okay, you have to notice if you have x minus I is a if I is 0, then if I is 0, then negative I is also 0. Okay, so most of the time they probably say that okay, 0 is 1, negative 2, I, and negative I, but they might miss the negative I. Okay, or they give you negative I and they don't give you I. Okay, they don't have to give you that. You have to figure it out yourself. Okay, so if I is 0, then negative I is also 0. That's why we have another factor over here, and you go ahead and add them up, give you 2, 1, 3, 4, 2, 3, 4, 5. See, 5 degree over here. Okay. So now you go ahead and plug the value in. So this is 1, A is still there because we want to find so negative 1 square, right? So which is I'll give you negative 1 plus I, and this one is negative 1 minus I, negative 1 plus I. Okay, so let's see what happened over here. So you have 1 A, which is give you 2, so it's 2 give you 4A. Okay, so this is negative 1 plus 2 is just 1, throw it away. So this is, go ahead and distribute it, so give you go ahead and distribute. Okay, this is 1, so give you negative 1 square minus I square. Okay, let me see, this is good or not. Okay, so what to give you? So we give 1 for A, so this is give negative 1 square is 1, I square is negative 1, negative become 1, right? So become 1, so this is mean that 1 equal 4A times 2, which is 1 equal AA, right? So A will be what? A will be 1 over 8. A will be 1 over 8. Okay, then your function will be what? F of x equal to 1 over 8 x minus 1 square x plus 2 and x minus I x plus I. There you go. So that will be your final answer. Okay. If the question doesn't give you the point, okay, so if the question doesn't give you the point, then you assume that A equal 1. Okay, so I'm going to put a notice over here for you to remember. Rima. if one is not given, then we assume a value equal 1. Alright, so remember that. Okay, you know, the purple color is kind of hard to say, right? Yes, it's nice, beautiful, but it's kind of hard to say. Maybe let me use this one. Oh, this one is nice one. I'm gonna use this one next time. Okay, so remember that. Alright, so I think I'm gonna stop the lecture right over here. And remember, this won't be on the test over here. Okay, part 5 is not on the test, but part 4, part 3, all of this, it might be on the test. Okay, all of this, you know, the division, the remainder, the factor theorem, long division, which is this one, and the syntactic division will be on the test. For the ending behavior, you don't have to, but I mean, I will give you this next time, or maybe on the final exam. But it's good, you have to learn it, okay? Because it's good to learn this, because as long you understand the factoring form, then you understand the division and the remainder and all of this, okay? And more importantly, you don't learn just because you want to pass the test, or you learn because it's your knowledge and you want to pass the final exam. So at the end, you have to learn everything. Okay, so I'm gonna stop the lecture now, and please go through the lecture carefully and be prepared for the test. Okay. Then if you have any question, do not hesitate, send me the message.